Hello, today we are going to talk about graphing polynomial functions using the four-step process. Let's look at an example. So, sketch the following polynomial function using the four-step process. So, the function is f of x equals minus 2x cubed plus 4x squared plus 30x. So the four steps in graphing the polynomial function is finding the end behavior, then find the y-intercept, then find the zeros and their multiplicities, and then choose a test value between each real zero and sketch the graph. These are the four steps in graphing a polynomial function. So for the first step, we have to find the end behavior of the graph. So end behavior always depends on the leading term. Okay. So leading term here, the term with the highest degree, that is minus 2x cubed. So the leading coefficient a sub n equals negative 2, which is less than 0. And the degree is the exponent of the variable, that is 3. You can see that 3 is an odd number. So as per the leading coefficient test, the leading coefficient is less than 0 or it's a negative number and the degree is an odd number. So the graph rises to the left and falls to the right. The graph rises to the left and falls to the right. Or in other words, we can say the graph starts up and finishes down. So we got the end behavior. Then we have to find the y-intercept. So you remember the rule. We have to set x equals 0 in the given function. So when you set 0 in the given function, f of 0 equals negative 2 times 0 the whole quantity cubed plus 4 times 0 the whole quantity squared plus 30 times 0. So you will get 0. So the y-intercept is 0. The coordinate is like 0, 0, right? In terms of an ordered pair. Then the third step is to completely factor the polynomial to find the zeros and their multiplicities. So we know that the polynomial function is negative 2x cubed plus 4x squared plus 30x equals 0. So we set this part equal to 0. Then we need to factor. So factor out negative 2x. So you will get negative 2x times x squared minus 2x minus 15 equals 0. Then you can see that this is a trinomial. Again, we can factor this. So we need to get the product as negative 15 and sum as negative 2. So the numbers are negative 5 and 3. So the factors are x minus 5, x plus 3. So when we completely factor this polynomial function, the factors are negative 2x times x minus 5 times x plus 3. Then to get the value of x or get the zeros, we need to set each factor to 0. When you set negative 2x to 0, you will get x equals 0. When you set this factor x minus 5 to 0, you will get the value of x as 5. Then similarly, when we set the last factor x plus 3 equals 0, x equals negative 3. And the zeros are 0, 5, and negative 3. And you can see that in this factored form, each factor occurs only one time. So we can say that each 0 is of odd multiplicity because 1 is an odd number, so each factor occurs only one time. So each 0 is of odd multiplicity. And we studied about the nature of the graph at these zeros. with odd multiplicities. So the graph at these zeros, the graph crosses the x-axis. Now the last step is to choose a test value between each real zero. So we know that the real zeros are -3, 0, and 5. For convenience, I plotted this on the number line. And we need to choose a test value between each real zero. So the benefit of, or the advantage of finding these test values to see how high the graph will go or how low the graph will go, okay? So let's take a test value between these points. For example, just take -1. So when you substitute -1 in the original function, we'll get -24. You know how to substitute for x, substitute x as -1, then you will get -24. So corresponding to x equals -1, the y value is -24. And I took 2 points between these 0 and 5. 1 point is enough. And if you take x value as 2, then you will get the function value or the y value as 60. And when you take x equals 3, you will get the function value as 72. Okay, let's sketch the graph. So first we need to plot the zeros, that is -3, 0, and 5, right? So the graph crosses the x-axis at these points, and also the end behavior is the graph rises to the left and falls to the right, or starts up and finishes down, right? And using the test values corresponding to -1, it is -24, and corresponding to 2, it is 60, it's somewhere here, and corresponding to x equals 3, the function value is almost like 72. So we'll know how high the graph will go, how low the graph will go, and we can see the end behavior starts up, finishes down, and also at the zeros, the graph crosses the x-axis. So this is the graph of the given original polynomial function. Hope you understood the graphing of a polynomial function.